Welcome to our lesson on radicals, adding and subtracting. Okay, first, the definition. A radical is an expression, that means no equal sign, that includes a number or a radicand, a radical or root sign, and an index. So take a look. This is our radicand, and this is our index and our radical sign. Okay. Now, adding and subtracting of radicals must be done with like terms. There's the key right there. You cannot add or subtract terms that are not similar to each other. So let's look to see if these are like terms or not. There's a radical 5 and there's a radical 5. It doesn't matter what the coefficients are. We don't care. It could be anything it wants to be. That's not what we're looking at. We're only looking for the radicals themselves. Those are like terms. Here, radical 2, those are like terms. It doesn't matter what the coefficient's doing, just the radical. Now, you've got a radical 3 and a radical 4. Those are not like terms. It has to be the exact same radical. The radicand has to match both the radicands. You've got a radicand of 3 and a radicand of 4, not like terms. Here, your radicand is 2 and your radicand is 1, not like terms. And if they're not like terms, you can't do anything with it. It just stays the way it is. So that right there would be your final answer. And these two up here, we would actually go ahead and add or subtract them. So let's take a look on how that works. I've got a radicand of 10 and a radicand of 10. Awesome. They match. They're like terms. So I can go ahead and add them together. There's no coefficient here. So what does that mean? That means that there's an invisible 1. So they're asking us to add 1 and 5. 1 plus 5 is 6. You do not change your radical sign. You do not change your radicand. It just gets recopied. Because you're taking one group of these, adding 5 groups, and you're getting 6 groups of them. So it doesn't change whatever it is. Just like if you're adding puppies and puppies together, you're not suddenly going to get 6 tigers. It's the same thing as it was before. Take a look. You got a radicand of 22 and a radicand of 22. Those are like terms. We can go ahead and add or subtract them. Here they're saying minus and negative. If you remember, when two negatives collide with each other, it actually makes it turn positive. So we're actually going to be adding these together. So we're going to take the 3 and add an 8. So 8 plus 3, we're going to get 11. That means we have 11 of radical 22s. Notice I didn't change my radicand. It stays exactly the same. When you add or subtract, your radicand stays exactly the same. You're just increasing the number of radicands that you have. You didn't change what they look like. All right, take a look at this. Are these radicands the same? No. So that means that the only thing you can do is just recopy the answer and make sure that these are fully simplified radicands. So you'd have 9 times 2 and 3 times 3. That's not fully simplified. So we can actually simplify the radical 18. So that's going to be a pair of 3s. Because remember, we're looking for pairs because our index is 2. So we have 3 radical 2 plus 15. 10 is 5 and 2. Those are both primes, no pairs, so that's simplified as far as it can go. So this would actually be your final answer right here. And notice we still didn't add these two together because the radicands don't match. So you just leave it like that. That's as far as you can go. That's like saying you have a pile of lollipops and a pile of cars. You can't bring them all together and add them all up. They stay separate. All right, let's look at the next one. Do we have the same radicand? No. Is this simplified? Yeah, 5 is a prime number. It can't be broken down anymore. Is 4 simplified? Nope. The square root of 4, that's a perfect square. That should be 2. So we've got 4 radical 5, and we are subtracting a negative 8. And now, since we broke down 4 into 2 and 2, we're taking it out. So it's going next to the 8, being multiplied. And we don't have anything left for a radical sign. There's no leftovers, so there's no radical sign, so you can just close that. Now, PEMDAS says we deal with our parentheses first. So we're looking at negative 8 times 2. So that's going to be 16. Now, once you do that, you can then deal with that negative sign that you've got outside of the parentheses. So, if we're going to look at 4 radical 5, subtract negative 16, what happens when two negatives collide with each other? It turns into a big old positive. So you've got 4 radical 5 plus 16. I've got a radicand of 5 and I've got no radicand here. Not like terms, can't add them. This is going to be your final answer right here. Again, it's like having a big group of cars and adding lollipops to them. You can't. They just stay separate. All right, let's try some more. I've got radicand 5, like terms, awesome. And they're broken down as far as they can go to primes. So I can just leave them that way. Now they want us to take a negative 2 and a positive 4. If you have negative 2 plus 4, you're going to end up with a positive 2. So you have positive 2 radical 5s. So it's saying if I have 2 of these missing out of 4 of them, I just have 2 of them left. All right, let's look at the last one. Now, that one, take a look at the radicands. You've got 11 and 11, and those are fully broken down because those are prime numbers. So what we're going to do is focus on the whole numbers outside. So you're going to take 6.4, and they're asking you to subtract 6.4. What happens when you have 6.4 minus 6.4? It's all gone. So you would have 0 radical 11s, which we don't really write that, because if you don't have anything, you don't have to write it. So your answer would just be a big old nothing. Be 0. All right, 16 and 16. Are they alike? Yes. Are they fully broken down? 16, isn't that a perfect square? Don't we have a pair of 4s? They'd come out and nothing's left behind. So actually you would have negative 4.2, and you would be multiplying it by 4. The radical is gone now because we broke it down. Same thing here, it's also going to break down into 4 and 4. So you're going to add 7 and then times that 4. All right, so if you have 4 times negative 4.2, that's going to be a negative number. So let's do it out. If you go old school multiplication, calculator died, we got to do it old school. 4 times 2 is 8, 4 times 4 is 16, and it's got 1 decimal over, so it's going to be 16.8, and it's negative, because it was a negative times a positive, plus, and then 7 times 4 is 28. These are like terms. There's no radicand here, so this is just a regular addition subtraction problem at this point. Let's go old school again. You have 28 minus 16.8. You do actually have a decimal back there, and it's 0. So if you do your whole borrow and change, you have 2, drop down the decimal, 1, and 1. So your final answer then for all of this is going to be 11.2, right there. Turns out your radicands disappear. They're all gone. Now let's take a look at the last one. Are these the exact same? Yes. Are they fully simplified? Yeah, because even if we ignore that decimal and just call it the number 53, 53 is a prime number. We can't break that down anymore. So we're just focusing on 15 minus 16. Okay, if you have 15 minus 16, you're going to get a negative 1. So your final answer is going to be negative 1 radical 5.3. And some people don't like to write that 1 because it looks kind of weird and it almost looks like an L for variable, so they don't write it. They just write negative radical 5.3. And it's just assumed if there's no number in this spot right here, it must be a 1, which is what we have. So this would be your final answer. You could also write it like that and it's still considered correct. Alright, in order to add or subtract radicals, they must, absolutely must, be like terms. If the radicals are not like terms, you cannot combine them. Remember, you have to simplify any radicands. You can simplify them at the beginning, or if you want to, you can simplify them at the end. And that's it for our lesson on radicals, adding and subtracting.